Okay, the recording started. So, good morning, students. It is a class of geotechnical engineering, uh, lecture number 6 or 7, I guess. So, we are discussing about index properties of soil from 2, 3 classes. Okay. So, yes, in the last class, previous class, we have discussed about grade of soil. Okay. Um, Types of soil based on sizes, and then standard classification of soil. We have also discussed about particle size distribution, why it is done, how it is done. Okay, all these things we have discussed about this. Okay, today we'll discuss about uh, next the another index properties of soil, that is called consistency of soil. Fine. Okay, so this term, this is consistency. This term mainly this property is mainly related to fine grained soil. I think in the last class we already discussed about types of soil based on sizes. So in general, we get fine grained soil and coarse grained soil, isn't it? So fine grained soils are those which have more than 50% of soils are finer than 0.075 millimeter or 75 micron sizes. Okay, I think you have know this thing, or we have already discussed in the last class. Fine. So this consistency, this term is mainly related to fine grained soil only. Okay, and actually this term also depend on the amount of water present in a particular soil. Okay, so it's also related to water content. Fine. This consistency of soil, it is a property of fine grained soil, and it is related to water content. That is the presence of water. How much percentage of water present in a particular soil mass. Fine. Okay, so first I will do a screen sharing now. Just a second. My screen is visible, right? Okay, wait. So here, is it visible? My screen is visible or not? You have to respond, okay?
Yes, sir.
Okay. So yeah, we are going to discuss about consistency of soil. Okay. Okay, someone is waiting in the lobby. Wait, let me unlock the fine. Yeah. I'll do one thing again. I'll just open the note also. Let me check where is the note. This one. Yeah. So yeah, we are discussing about consistency of soil. Fine. So what is consistency? So consistency, it is a relative is. Let me see first. Wait. Yeah. So consistency is what? It is a relative ease with which a soil can be deformed. That means whether the soil can be deformed or not. How much can be deformed? Okay. That property is mainly related to consistency. Okay. And it is applicable to fine grained soil that we already discussed. It is applicable to fine grained soil whose consistency depend on water content. Okay, and this term, that is consistency, it was first proposed by, or it was discussed by a Swedish agriculturist. His name is Albert Atterberg. Okay, in short, A. Atterberg. Fine. So this is the name of a Swedish scientist, you can say. In 1911, he proposed this concept of consistency. Fine. And he proposed that depending on the water present in a particular fine grained soil, a fine grained soil uh, contain four stages. Okay, so depending on the presence of water in a particular soil, we are talking about especially for fine grained soil, a soil may attain four stages at different water content. Okay, so they are liquid state. I think we'll discuss it. I think here. Wait. Yeah. So depending on the water content, a particular fine grained soil may attain maybe in a four stage. Okay. So here you can see liquid stage, plastic stage, semi-solid stage, and solid stage. Okay, so these are the stages of fine grained soil based on the water. You can also uh, understand this concept by this diagram, or it is a graph. Okay, this graph is representing what? In x-axis, here you can see the water content. It is increasing from left to right. Okay, from here to here the water content is increasing from 0 to 100%, say, or more than 100%. Okay, and the volume also is increasing in volume is representing in y-axis. Fine. So here you can see uh, water content is increasing in this direction, and volume is increasing in this direction. Fine. Now you can see the graph of variation of volume of fine grained soil with respect to increase in water content. It is shown by this red color. I think it is visible, right? This red color curve, this you can see this is a linear straight curve. This is a horizontal straight curve, isn't it? So this curve, this red color line represents the variation or relation between volume changes with respect to water content for a fine grained soil. Okay, and at different water content range, at different water content ranges, the soil must attain four stages: liquid stage, then plastic, then semi-solid or solid, or vice versa. Means solid, then semi-solid, then plastic, then liquid. Okay. Now, why this curve is is horizontal, is completely horizontal up to this point? Then why it's increasing like this? We'll discuss in coming time. Okay. So for now, you just concentrate here. The soil mass contain four stages. We are talking about only fine grains. So fine, liquid, plastic, semi-solid, and solid stage. Fine. And here you can see this point, this line, or this line. This line you can say the border line. Okay, this line divide solid to semi-solid. This line divide plastic and semi-solid, and this line divide liquid and plastic. Fine, it is very simple thing to understand. And the water content corresponding to this point, it is known as shrinkage limit. Water content corresponding to this point is known as plastic limit, and water content corresponding to this point is known as liquid limit. Simple, easy to understand for now. Okay, there are different definition also for liquid limit, plastic limit, shrinkage limit. We'll go into the definition, but still now, for basic definition, to understand the graph, you have to remember this graph. Okay, the behavior of soil, behavior of fine grained soil with respect to presence of water content. Okay, always the graph will be like this. Fine, and it is always from solid, then it will become semi-solid, then plastic and liquid. Okay, the sequence will be always remain same. Okay, you have to understand this graph. I will not say remember this graph, you have to understand this graph. Okay, if you understand, you will be automatically remember. Fine, is it okay for now? Can you respond in chat box? Did you understand till now? समझ में आया कि नहीं?
Yes, sir.
Okay, fine. So let's move on to the next slide. देखते हैं क्या होता है. हाँ. So now we'll discuss about the definition of liquid limit, plastic limit, and shrinkage limit. Let's see what this limit is all about. So before that, I want to add one more thing. I forgot to tell you that we are discussing about consistency of soil. Okay, fine. And this shrinkage limit, plastic limit, and liquid limit, this all these three limits together is known as consistency limit. Fine. This all these three, this liquid limit, plastic limit, and shrinkage limit, all these three together known as consistency limit, and it is proposed by Albert Atterberg in 1911. That's why these consistency limits are also known as Atterberg limit. Okay, so these consistency limits are also known as Atterberg limit. Okay, don't forget. Okay, some exam you may ask define Atterberg limit. Okay, so these are similar to consistency limit, same thing as it is discovered or proposed by Atterberg. That's why this consistency limit also known as Atterberg limit. Fine. So let's go through the definition of liquid, plastic, and shrinkage limit. Okay. Yeah. So in general definition, here you can see the liquid limit. It is what? It is a arbitrary water content between plastic and liquid phase of soil. I think it is a very simple definition. So here you can see this liquid limit boundary line divide liquid and plastic. Okay. So it's an arbitrary limit. It is not fixed. Depending on the different types of fine grained soil, for some different fine grained soil it may here or somewhere else. Okay, the range is not fixed, but sequence is always fixed. Okay, that means after plastic limit or after plastic stage, if you increase water content it will come to liquid limit. Okay, the sequence will be fixed, but the range it is not fixed for all the soil. It may arbitrary. Okay, that's why it's known as wait, that's why it is known as it is a arbitrary water content. It is not fixed. Okay, arbitrary water content between plastic and liquid phase of soil. It is also known as okay, it is the water content corresponding to the arbitrary limit between plastic and liquid state of consistency of soil. Okay, it is also defined as the minimum water content at which the soil is still in the liquid state. Now, why it is given like that? Here you can see it is the minimum water content in the soil where it behave as a plastic material. Okay, and it is the amount of water in the soil where the soil contain least amount of shear strength. So this point is very important in some exam. This term always asks, usually asks. Okay, so at liquid limit, the soil contain a minimum amount of shear strength. Okay, maybe you are not getting the shear strength chapter, but still try to remember now. You will get the this term. You will get the introduction of this term in coming classes. Okay, but try to remember this. Okay, so why it's called like that? Let me show you in the graph again. So say example once soil is there. Okay, and it has a um, liquid amount more than liquid limit. Okay, suppose there is a water content which having more than this point, that in that case the soil behaves like liquid. That means it will flow like liquid if it cross the liquid limit point. Okay, now that's why it's called it is the minimum water content. Okay, because the liquid stage of soil start from here. Okay, that's why it's called this point. It is defined as the minimum water content at which the soil still in liquid stage. Okay, that means after this, if you reduce the water content beyond this point, it will come to the plastic stage. Okay, okay. So if you X second, huh? Hold on, please. हेलो. हाँ, तुम एक काम करो, अनन्या मैम को फोन करो. हाँ, एग्जाम रिलेटेड, अभी मैं क्लास में हूँ, ठीक है. ओके. Okay. So here, so this point it represents as a minimum water content at which the soil is still in liquid stage. Okay. So all these points be in the right side of this point, all these point this means this water content. Okay, we are talking about this water content. At this water content, soil is in liquid stage. Okay, and this is the last point at which the soil will be in liquid stage, because since it is decreasing in this direction. Okay, that's why it's called minimum water content at which the soil is still in liquid stage. Fine. Next, we'll discuss about plastic limit. Okay, wait. Yeah. So, what is plastic limit? Like the similar definition, it is the minimum water content at in the soil at which it, okay, we'll go to beyond ये बाद में बोलेगा पहले इसको पढ़ लो. So, it is the minimum water content. Okay, or it is also known as it is the arbitrary water content between plastic and semi-solid state. Okay, let's first discuss the basic definition. So plastic limit, it is the water content corresponding to the arbitrary limit between plastic and semi-solid state of consistency of soil. Okay. Now again we'll go to this diagram. You can see this plastic limit. It is the point. X second. Okay. So this point, which is represented as a liquid limit. Okay. Sorry, plastic limit. This point represents as a water content corresponding to the arbitrary limit between plastic. Here you can see plastic and semi-solid state of consistency of soil. Okay, so I think from the diagram also you can find out the definition. It is the boundary point between plastic and semi-solid. Another definition is what? It is also defined as the minimum water content at which a soil will just begin to crumble when rolled into a thread approximately 3 millimeter in diameter. Now, what is all this about? Even here also it written it is the minimum water content in the soil at which a thread formed by rolling on a glass plate crumbles at 3 millimeter diameter. Okay, so to understand this term, you have to understand what is plasticity. Since it is known as plastic limit, why it is known as plastic limit? Because if the water content ranges between this point to this point, the soil is known as in plastic stage. Okay, now why the soil is termed as plastic. I think you know the behavior of plastic. What is the behavior of plastic? It can regain its original shape even after the release of the force, isn't it? So, what is plasticity? So, it is very basic physics, isn't it? So, in general, what is plasticity? It is defined as that property of a soil which allow it to be deformed. To be deformed, matlab to take any shape. Okay. So, plasticity is defined as that property of a soil which allows it to be deformed rapidly without rupture, without elastic rebound, and without volume change. Okay, so I can also repeat this. So what is plasticity? It is a property of soil. Okay, it's a property of soil which allows it to be deformed rapidly without rupture. That means without failure or without breakdown, without rupture, without elastic rebound, and without volume change. Okay, so yeah, okay. I just give some little correction is there. So what is plasticity? Plasticity is what? If you stress something by applying a particular external force, okay, it will deform. Okay, it will take different shape, and after the release of the load also, it will not regain to its original position. Okay, if it regain, then it will call elastic. If it will not regain its original position, it will call plastic. Okay, so be clear about that. I maybe got some confusion here also. Fine. So be clear here. What is plasticity? Is the plasticity of soil? It is a property of soil which allow it to deform rapidly without rupture, without elastic rebound, and without volume change. So I think you will see this kind of soil. I think Durga Puja is coming nearby, isn't it? So whatever the soil is will be used for the construction of that क्या बोलते हैं इसको, the Durga Ma Murti, so this soil, what kind of soil it is used for that, for construction of that soil is used, that is plastic soil. Why? Because plastic soil can be deformed easily and can be made in different shape. Okay, because it will not regain its original position even after the release of the load. This is the property of plastic soil. Okay, so you have to remember that plastic soil is used to construction of that culture. Okay, any kind of statue or anything. Okay, so you got this idea about plasticity, it is a property, you got this. Now the now concentrate here, the definition of plastic limit. That means if you see in this कहाँ गया? Wait. Yeah, so if you see in this diagram, the water content is increasing in this direction. In other word, you can say water content is decreasing from right to left. Okay, same thing, isn't it? Water content is decreasing from right to left. Okay, now if you say water content is at this point, okay, at this sorry, water content is at this point, you can say soil is in plastic limit or plastic stage. Okay, now let's decrease some water content from the soil. Suppose here, if the water content is reduced to this point, still the soil is in plastic state. If you decrease up to this point, still in the soil is a plastic state, isn't it? So this point, the this point which is represent as plastic limit, this is the minimum water content at which the soil is in plastic limit, sorry, plastic stage. Okay, and if you just reduce little bit water content from this point, the soil will not be in plastic limit, sorry, will not be in plastic stage. Then what will happen? If you try to deform the soil, if you try to remold the soil will get some crack in their surface. It will represent the soil is not in plastic stage. Okay, now if you comparatively, if you take one soil sample from this point, that means containing this water content, if you try to remold the soil, okay, by your hand, it will take different shape without any rupture, without any failure. It will not, you will not see any failure pattern in the surface. Okay, because this in this stage the soil is in plastic stage, fine. But when it come to this point, that is in plastic stage, sorry, plastic limit, if the soil contain water content corresponding to this plastic limit, and if you try to remold the soil, okay, then maybe it will give some fracture or failure surface above the surface, surface of the soil. Okay, failure pattern will visible in the surface of the soil. It will indicate that the it reached plastic limit. Okay, from this point the definition come here. Okay, now we can see the definition here. What is this? Your definition of plastic limit? It is defined as the minimum water content at which a soil will just begin to crumble when rolled into a thread approximately 3 millimeter in diameter. Now, if you take a particular soil sample, okay, containing water content corresponding to this plastic limit, say, for example, and if you take make a roll, okay, like a laddu, okay, make a roll of let's say 10 gram of soil within your palm and try to roll within your hand, okay, between your palm, and try to roll it, make as a thread, okay, and try to make the thread of having diameter or size approximately equal to 3 millimeter. Okay, where it is called, yeah, approximately at 3 millimeter diameter of thread. Now at this point, if some failure pattern will visible, failure pattern or crack or the thread will break down, then you can say the soil is in plastic limit. Same thing, if you do this experiment for this soil, that means having water content more than this liquid, plastic limit. If you take 10 gram of soil, and if you try to make a thread of approximately 3 millimeter diameter, then it will not be cracked, or there will be no any failure pattern will be visible in the surface of the soil thread, since the soil is in plastic stage. Okay, but in case of plastic limit, if you make the soil mix with water content corresponding to plastic limit, the soil thread of having 3 millimeter diameter may crumble or may get breakdown, or failure surface may visible in the surface. Then you can get, this is the plastic limit of soil. Then you can go for water content determination. Okay, so this is also a procedure how to find out plastic limit in a laboratory. You will also, I think if you go through your student portal, you will get some procedure or guiding reference video also will be there to find out to how to go for laboratory test for determination of plastic limit of fine grained soil. Okay, you will just go through this. The procedure is this thing only: make a thread of 3 millimeter diameter, and you have to check whether failure pattern will come or not. Okay, fine. So yeah, this is all about today class. Okay, because exam will be going on for the betterment exam and comparative exam, so I have to be busy with that. Okay, so in the next class we'll go for this shrinkage limit, discussion of shrinkage limit. Okay, and we'll discuss some details of different limits. Okay, and also discuss some different other index property also, like plasticity index, consistency index, okay, liquidity index, all so small important parameter also there related to consistency of soil. Okay, so we'll discuss about this in next class. Fine. So till now I just want to stop my sharing now. Okay, do you understand? So, anyone, please do one thing. If Sierra is present here, do one thing. Since I will not be able to take the attendance now, do one thing. Take the photo, screenshot of the participation list, okay, and send me in WhatsApp. Is it possible for you? Take photo of the participant list. That's why I'm talking. Take the participation list, okay. Take the photo. I'll give the attendance. Okay, don't worry. Anyone, please take the photo of the participation list and send me in WhatsApp.
Is not present.
Okay. So, is it okay for you?
Here is
Fine.
not present.
What? So you do one thing. Just give me the screenshot. Okay, anyone? Fine. So I have to go for that exam duty. Okay. So I'll just stop my class here. Okay. So whatever you have doubt, we'll discuss in the next class. Fine. Is it okay? So
Yes,
I'll
sir.
just close.
Sure.
I'm just closing this classroom. Okay. Thank you for attending.